Hi, welcome to the Olympiad geometry. Let's continue our study of Simson line theorem. Here is the problem. P is any point on the circumcircle of triangle ABC. PL is perpendicular with BC on L. PN is perpendicular with AB on N. LN intersects altitude of triangle ABC on edge BC on K. Right, so this is the altitude of triangle ABC, that BC edge altitude. Let H to be also center of triangle ABC. So we do this altitude, so that intersection point is also center H. Prove PK is in parallel with LH. So for this problem, we actually, when we see this problem, it should remind us a problem we saw yesterday, where that we find the, in yesterday problem, it calls here as D, right? And we find a P prime that's equal to, P prime D equal to PD, which means that P prime basically is a symmetrical point from P to the line BC. So we still find it here. Let's call it P prime again. And in yesterday problem, we just proved that P prime H is in parallel with the Simson line, right? So we know we can just use it for this problem, right? P prime H is in parallel with Simson line, that is LK, right? And we know that P prime L is in parallel with HK, right? So it's a parallelogram. Then we know that P prime L equals to HK. And we already know that P prime is a symmetrical point of P to the line BC. So P prime L equals to PL, right? So PL equals to HK, and PL is in parallel with HK. So PKHL is a parallelogram as well, which means PK is in parallel with LH. Sorry, here should be LH. That's a mistake. Yeah. Right. PK should be in parallel with LH. That's it. That's a problem. So it's very easy when you already find a lot of relations in one figure. So based on this, I just want to point out that if we connect the P and H, right, we would find, because PKHL is a parallelogram, which means the diagonal line which means that the intersection point, let's call it for example Q, right? So we know that PQ equals to QH, right? Q is the midpoint of the PH. And I also want to show another thing, that because P prime is a symmetrical point of P, so if we find any symmetrical point of P on the line AC or AB, right? So let's do another line here and do another point here. we already proved that this point, and this point, these 3 points are collinear and in parallel with the Simson line. And we know that P prime H is in parallel with the Simson line, which means these 4 points are collinear, right? So all the symmetrical point and the H are collinear. That's basically very interesting character of this problem. So look at this problem. It's actually not a very simple problem. It's the solution is very short just because we already went through a very long detailed derivation yesterday for about half an hour. We proved that P prime H is in parallel with LK, and keep this in mind, then we could easily find other things. Okay, that's today's video. I hope you like this one. Thank you. See you in next one.